Welcome to the OGC Earth Observation Applications pilot video on Docker deployment. This has been recorded by Dr. Samantha Lavender, who is the Managing Director of Pixalytics Limited. Why did we get involved in this pilot application? Pixalytics is increasingly involved in the development of applications or apps that need to be run in near real time as part of automated operational services. And therefore, we've been developing cloud deployed apps that are running in a cloud environment that we've set up locally. But in the long term, we're looking to expand. And the reasons for this is to be able to use additional cloud platforms so that as we have particularly demanding jobs, we can elastically expand to have those on-demand resources as they are needed, or to also deploy our apps within other platforms where they're available as part of third-party workflows. So I'm going to start by giving you a summary of the overall process. So the first step in involving ourselves in the pilot was to choose an app that we wanted to experiment with. And we chose a particular application that's called Mosaic. And the reason for that is that it's one of our simplest applications, and so we could focus on the process as this is our first involvement in a OGC activity. Mosaic uses a curated set of Landsat 8 scenes and creates a cloud-free pseudo-color geotiff that is used in many applications that are much more complicated than this, where a colored backdrop image is needed. And the way it works is the user specifies their area of interest. So you have the created archive of the Landsat 8 data, you have the user giving your input latitude and longitude coordinates, you clip all the Landsat 8 scenes that are in that area of interest, and then the final step is you merge those scenes with individual histogram stretching so that they are joined seamlessly together and look like a single image. We also have the option of applying an atmospheric correction, but that was not tested in the pilot. What we are focusing primarily on in this video is the containerization of that app. And then the final stage would be the deployment to a platform and running that app on the platform and getting the correct output. So in terms of the actual containerization process, we decided to go through a 3 Docker image process. So we have a base Docker image, which is the Linux Miniconda environment that comes pre-configured and externally provided. We then create an intermediate image that allows us to set up the configuration of the Conda environment needed for the Mosaic application to run. And then the third stage is to create the deployed images, and that depends on where that deployed image is going to run. So we have one version that is a local Docker file, and that image has the possibility to mount local volumes with this curated data set on it. We then have a Mosaic remote version of the Docker file, which is for remote deployment somewhere else. And in that case, the data is instead held in an Amazon S3 bucket and downloaded as the process is run. And we have a third version that we haven't focused on this pilot, and that's because we have a REST API access to the Mosaic code, and we're going to build a specific Docker image for that case. So I'm going to just show you now this process running. It's been very much shortened for the purposes of the video, but will give you some idea of the commands and output that happens. So this is building up to the second Docker image. So the first thing we decided to do in order to make the deployment of our Python Mosaic application easier was to compile it. So we use PyInstaller to do that, and it allows us then to have a distribution directory. We then create the Conda environment, pull the mini Conda image, and then as the last step we will build the Mosaic image itself. And you can see there are a lot of Python modules being used in that process. When we have got to this step, then we have our second Docker image, and as we need to test out different things within using the third image, then we can always start from this second Docker image which exists. In terms of building these images, we have taken that process using a YML file that defines them. So you can see on this slide that we have the name of the intermediate Mosaic environment Docker file. And then we also have, in this case, a Docker file image that we're going to deploy on the Spacebell platform. And in order to build that particular image, we have a series of steps in that process. So it pulls in the Mosaic environment image, it copies over to the container the data files for the Mosaic code now in its executable distribution folder. We have the WS scenes for Landsat 8. And this is the specification of them that is used to convert the latitude longitude coordinates into the code knowing which Landsat 8 scenes it knows. And then we set up a number of environment variables. And these include the 4 corners of the area of interest that are being extracted. So you have the southwest latitude, southwest longitude, northeast latitude, and northeast latitude. And we have the command itself that's now being run as an executable with those inputs. Because we're downloading the curated data from AWS, we set up a credentials folder for that and say that the credentials for that download are in that folder. We are also copying across the Landsat 8 MTL files themselves, which are very small text files describing each of the Landsat 8 scenes, and that saves them being downloaded. We specify the output directory, and we also specify a Spacebell environment variable, which will tell the Docker container where to put the output image when it's deployed on the Spacebell environment. So we now have the third Docker image built, and so the final step I'm just going to show you is running the Mosaic application, but in this case just locally using the CWL tool and a CWL definition of how to run that container. So in the CWL file, we define all the environment variables that have been predefined when building the Docker image, but this allows you to change them as needed. So for a particular application and user, the area of interest will change. So although there's something pre-built in the image, actually you can specify a new set of coordinates as you run the Docker image. And it will then run through the process of clipping the individual files within each of the needed Landsat 8 scenes and performing the histogram stretching in this particular case. So the result of this is on the left for what we were doing primarily in this pilot, which was just testing a very small area, in this case covering the Plymouth in the UK, which is where Pixalytics is based. And we used a small area for the pilot testing because every time we were running the container remotely, it needed to download the Landsat 8 data from the Amazon S3 bucket. But on the right is an example of a larger area that's been selected and run. So in this case, there is more than one Landsat 8 scene. And so the user doesn't have to know that themselves. The advantage of this application is the user supplies any area of interest they're interested in, and that could be the whole of the United Kingdom. And then it's the code itself that works out which Landsat 8 scenes are needed and sticks them all together. So I'm just showing here with the little box where Plymouth is on that particular larger scene. So in terms of our conclusions and recommendations, we found that containerization using Docker is beneficially undertaken as several steps. Particularly in the pilot application, we found that we needed to build the last image multiple times. And by not having to go through the first two steps every time, that sped up the process for us. We also found there are several different ways to build a Docker container, and you might well do that differently when you're deploying remotely to a cloud versus how you would run that container locally. So in the local case, we mount partitions within our containers so that all the files are held locally and don't need to be downloaded. But that wasn't the optimum solution on someone else's cloud deployment. We also found it useful to turn the Python code into an executable so that the dependencies were reduced and we could deploy it as a simple distribution folder.